Drawing molecular compounds. Drawing Lewis structures and structural formulas to represent molecular compounds. For this example, we will look at bonding 3 oxygen atoms with 1 sulfur atom to determine the result. Using your periodic table, determine the bonding capacity of each element. Remember, the bonding capacity is the number of electrons lost, gained, or shared by an atom when it bonds chemically in order to achieve a stable octet. Oxygen needs 2 electrons to achieve a stable octet. Sulfur also needs 2 electrons. In our example, we will see that both an atom for oxygen and sulfur each need 2 electrons, but by looking at how many atoms in total, we see that there are 3 oxygen and 1 sulfur, so we will put S in the middle as there are fewer number of electrons in total. As we said, we're going to use 3 oxygen atoms and we're going to bond with 1 sulfur atom to see the results. To do this, we're going to add up the valence electrons available in each of the atoms as we've set them up in number 1. If the structure is a polyatomic ion, add 1 electron for each of the negative charge or subtract 1 for each of the positive charge. So in our calculation, we have 3 of oxygen, and the bonding capacity of oxygen, it has 6 electrons, and sulfur has 6 as well, so there are 24 possible. Now, place each pair of electrons between each adjacent pair of elements, forming single covalent bonds. So we have oxygen with 1 pair shared with sulfur, another pair from oxygen to sulfur, and another pair from oxygen to sulfur. Next, we're going to add the remaining valence electrons as lone pairs on the peripheral atoms, not on the central atom. So I've shown the original bonding in blue, and the remaining lone pairs I'm showing in red. So that brings us up to 8 oxygen, 8 oxygen, 8 oxygen, and still we have 6 with sulfur. Number 6, if the peripheral atoms all have complete octets and there are pairs of electrons remaining, place these electrons as pairs on the central atom. So we have our left side, and now we can see the full bonding. So sulfur has 8, and the 3 oxygens have 8. Some are being shared, which makes it covalent bonding. But you can see that the sulfur has a complete octet now. And the purple arrow on the first diagram shows the sharing of the electrons between the bottom oxygen. Now you're going to count the number of bonds between the central atom and the peripheral atoms. If this number exceeds the bonding capacity of the central atom, one or more of the bonds is a coordinate covalent bond. To identify which ones are, try removing the peripheral atoms one at a time. If you can do this and leave the central structure with complete octets, you have identified coordinated covalent bonds. Number 8, to give the structural formula, remove the dots representing the lone pairs and replace bond dots with dashes. This is now our structure. If you are representing a polyatomic ion, place brackets around the entire structure and write the charge outside the bracket. Just a glimpse of what is to come.